Good evening, sir. My name is Santosh from CSSC section, SRIT. Today, my topic is particle in one-dimensional potential wave. It is in the topic quantum mechanics. First, to observe the diagram, where what is this? V is equals to infinity, V is equals to infinity, V is equals to zero. What is the meaning of this? After that, introduction. A particle in one-dimensional potential is a fundamental concept in quantum mechanics used to illustrate how particles behave under the constraints of quantum rules. Explaining quantum mechanics, how the rules are executed, how rules are followed. In this model, a particle like an electron is confined to move along a single spatial dimension and is subjected to potential that varies with position. A particle having some velocity, some position, some acceleration. These are some basic terminology used. The simplest form of potential is an infinite potential well or infinite square well, where the potential is zero within certain region. From x is equal to zero, capital X is equal to small x is equal to capital is equal to L. Infinite out of this region, confinement force or particle remain the bounded by the well. We know what is the brief classification of potential well. What are the rules are followed? What topic is involving quantum mechanics and classical mechanics? First of all, we have to know classic mechanics. The state system is described by the specific values of position and momentum for each particle. In principle, it allows for precise measurement of both position and momentum simultaneously. Treats particles and waves are distinct entities. Particles have well-defined position and velocities in classical mechanics. By coming to quantum mechanics, introduce wave particle and duality because of wave are two particles, wave form and particle form, where the particle exhibits both particle like wave particle like electrons. The state of system is described by the wave function, governed by the Heisenberg uncertainty principle, where the states that the precise one property is force and precise complement is momentum position. Precise one is position, precise complement is momentum. This is me. After that explanation, how it is going on. Consider a particle of mass m moving back and forth between the walls of one-dimensional box separated by distance a. Let the particle travels only along the x-axis and is confined between x is equal to 0, x is equal to a by two infinite, infinitely hot walls, so that the axis particle has no chance of penetrating them. It does not lose energy when it collides with walls and its total energy remains constant. This box can be represented by a potential box of width with the potential walls of infinity at x is equal to 0 at x is equal to a, so that potential energy comma b of the particle is infinitely high on both sides of box and inside b is uniform. Let us assume that let that b is constituted inside the box. Inside the box, mass is rotating the some distance a is separated by the distance 0 to x, and again v is grabbed around v is equals to x and infinity, and again particle is rotating in this region. After that, by the doing that, score in the wave equation. Score in the wave equation. Vx is equal to 0, where 0 less than x, x less than e. These are the conditions where Vx is equal to infinity, there x less than or equal to 0 or x greater than or c. Then the wave function phi of x of the particle is then x is greater than x. By doing that, these are dou psi function by dou x square plus 2m by h cut square e phi is equal to 0. These are the double time differentiation. By doing double time differentiation, the formula was framed k is equal to square root of 2me by h square. The solution for the above equation is given by psi of x is equal to a sin of kx plus b cos kx, psi of a is equals to a sin x k is equals to 0, a net a naught is equals to 0. In case of a equals to 0, the whole function will be a. In this case, a naught is equals to 0. That's why sin k is equals to 0. After that, eigenvalue of energy. So by doing squaring, k square is equals to me h square. By framing that, energy is equals to k square h square by 2m. By substituting k value, En is equals to n square h square by 8ma square. By the spacing equation, spacing between nth energy next level, n plus 1 square into E1 minus n square into E1 is equals to 2n plus E1. Wave, in case we learned energy eigenvalue wave, but in this case eigenwave function. In that, in case a is equals to 0, then psi is equals to 0. Probability of the particle is where must box is unity. That's why a square into 0 to a 1 by 2 into 1 minus cos 2 pi n by x by a into dx is equals to 1. By integrating, we solve that. Second term becomes 0 at both limits. Yes. In this case, both terms 0. A square by small a by 2 is equals to 1. By raising a is equals to square root of 2 by a. The normalization of a function is psi is equals to root n by a into sin n pi by a. After that, the graph is most of the different. In this case, wave function, by the touching both positive of the graph and negative of the graph. In this case, only positive. In this case we easily say that variation of wave function is both positive and negative. In variation of particle density only in a positive direction. Similarly, formula is p of 2 by e sin square equal n pi by a. This is formula. By understanding that both wave equations are considered as potential energy En is equal to n square ma square. Applications: quantum dots, semiconductor devices, nanotechnology, molecular and atomic physics, and tunneling devices, optoelectronic devices. Thank you.